Hello everybody, we're going to be talking about net ionic equations today, which essentially is taking a precipitation reaction and just getting to a little bit more detail on it. So you already have a lot of this on your sheet, and we've talked about some of this already in class, how if I have a solid like sodium chloride, and if it does dissolve in water, it's going to break into its sodium ions and its chloride ions. And since it's a 1-to-1 ratio, I would get one chloride ion for every one sodium, or back and forth, one sodium for every one chloride. Something like aluminum chloride, however, has a 1-to-3 ratio of ions. So when it separates, and this is just showing that that's happening in water, it would break into one aluminum ion and 3 chloride ions. So if I started with 1 mole of both these things, I would get 1 mole of these ions, 1 mole of these ions. But if I want to think about having 1 mole of this substance, I'd get 1 mole of these ions and 3 moles. So I'd end up with more ions with something like this in solution. So if we wanted to apply that to what we did with our lab a couple weeks ago, that would light the light bulb more because there's more ions in the solution than here if we started with the same amount of each. But just notice how, since we have a ratio of 1-to-3, that we show that 3 here. That subscript is shown here for the number of ions. And this is coming from 7.7 if you want a reference for where this is coming from in your book, Net Ionic Equations, just a little bit more than what we've done before. So dissociation, we've kind of talked about this already, how things break apart in water. This is just be a way to show that with an equation. You really want to do this with the lab that you're doing tomorrow, and that the lab is really an application of what you're learning here. But I just wanted to show you how they break apart into different ions, because you will need that when you're writing your equations in a little bit here. So, just as some review, I know you have some of this on your, or all of this written down on your sheet already. So this is the demo I showed you last week where I put 2 liquids together and made a yellow solid, yellow precipitate, and that was this stuff right here. It was a yellow precipitate. The solid was. We went through this as a practice problem last week. This is the chemical equation that we made, and then we took it a little bit further and made it a balanced chemical equation. But what we're going to do now, so this is all review from what we did in chapter 7 so far, but we're going to take it a little bit further. So if you flip the page, I know again you have this stuff, but notice how this is our balanced chemical equation now. There's 2 potassiums and 2 nitrates, 2 iodines, because we put the coefficient of 2 in front of it. Now we have some new equations that you haven't seen before. So this is a balanced chemical equation. This is called a complete ionic equation, and then a net ionic. So what you're doing is you're taking anything that's aqueous and splitting it apart into its ions. So if you can see here, the lead, which is a +2 ion, and you show those charges. Here we have 2, the subscripts of what the ratio is, ends up in the front here. So there's 2 of those, and if there is a coefficient already, that is also in the front, because this also needs to be balanced. So there's 2 potassiums, 2 potassiums, 2 iodines, 2 iodines stuck there, 2 nitrates, 2 nitrates. So anything that's aqueous, I'm splitting apart into its ions, because that's truly how it would exist. So it's showing all the ions how they are separated, because they really wouldn't be together anymore in the solution at all. Those ions are floating around, and we've talked about that a fair amount already. Here are the potassiums, but there's also a 2 in front of this for the nitrates, so there's 2 nitrates. But this is our solid precipitate, so that is together. So we keep that together as a solid when we write our complete ionic equation. We're taking everything that's aqueous, breaking it apart into its separate ions, and the solid we keep together. But you'll notice how there's some ions on the left and the right, these nitrates and these potassiums, that don't change. They're the same on the left and the right. And those guys are called spectator ions. They are ions that are not doing anything. They're not changing. Where if you look at the other ions, these lead ions and these iodide ions, they started as ions. Now they're part of a solid. That's a change. That's something different than it was before. So when we eliminate those spectator ions, what is left is called the net ionic equation. The change that is actually happening in this reaction is these ions becoming this solid. So in your lab that you're going to be doing tomorrow, you're going to be writing a balanced chemical, a complete ionic, and a net ionic for any reactions that actually make it precipitate. And I'll talk more about that lab in a little bit. I would like you to try this first. So pause the video, and you're going to pause the video after I get done telling you what you're going to do here, but you're going to try and come up with the rest of this word equation, then the balanced chemical equation, the complete ionic, and the net ionic. Look at the example above on your sheet to try to do the same thing, because this is what you'll need to be doing on your lab that we're going to talk about. So go ahead and pause it now, and once you're done, just play it and check to see how it went for you. All right, we're back. So I'm going to put down my answers. And it doesn't matter what order you go in, but I am going silver chloride as one product. Whoa, ran out of space there. So the silver is now going to go with the chloride, and sodium is going to go with nitrate. So my other product is sodium nitrate. So it's just a double displacement reaction like we've been practicing. But now I'm going to do the balanced chemical equation for that. So silver nitrate is AgNO3, and that is aqueous. Your two reactants are always going to be aqueous in these examples that we're doing and with the lab. That's NaCl. Silver chloride then is AgCl. And if you look at your solubility chart, you will see that that is insoluble, so that would form a solid. And then the sodium nitrate is soluble, so NaNO3, whew, that's tough to read, and that is aqueous as well. So now the complete ionic, I'm taking everything that's aqueous and separating it into its ions. But this is already balanced. You'll notice that there's plus ones, minus ones everywhere, so it's already balanced. So I don't need to worry about putting 2's in front of any of the ions like we did with the last one. But if I take everything that's aqueous and break it apart, there's silver with a plus charge, nitrate with a minus charge, plus sodium with a plus charge, plus chloride with a minus charge, yields AgCl. It's a solid, so I'm going to keep it together as a solid, plus sodium with a plus charge, plus NO3 with a minus charge. In this case, you'll notice that the sodiums are on both sides as ions, and so are the nitrates. So they are spectator ions. So I will drop those out for the net ionic equation, and we will have silver ions plus chloride ions making silver chloride. So this is solid. So that's the change that is happening. So those three types of equations is what you're going to be writing when you are working on the unknown liquid lab. So I'll show you what you will be doing for that lab next.